All right. So we have not yet done, well, I guess I did sort of an example. It was done for us with the dice of looking at a sample space or a probability model. We're going to go ahead and do an example here with a four-sided die. I don't know if any of you are nerdy like me and have ever played some RPGs, but there is a four-sided die involved there. And the way it works is it looks like a pyramid, and the number that's on the bottom is the number that you rolled. So you pick the thing up, you look at it, and that's the number that you rolled. We're going to imagine that you had two such four-sided dice, and you roll one and then roll the other. And we're going to write out the sample space. We're going to give a probability model for this situation. All right, so the way that I'm going to do this is I'm going to start with the case that I roll my first four-sided die and it's a 1. Okay, what are all the different combinations that could occur when my first die is a 1? And I'll write it like this. I'm going to say, okay, I rolled a 1. Well, I could roll a 1 and then a 1, right? So first die, second die. That's the first one. That's the second one. I could roll a 1 and then a 2, a 1 and then roll a 3, and then I could roll a 1 and a 4. And there you go. That's all of the combinations that I could have if I rolled a 1 with my first die. Okay. Now we can list all of the combinations that could occur if I roll a 2 on the first die. 2. I could roll a 2 and a 1, a 2 and a 2. I could roll a 2 and a 3, or I could roll a 2 and a 4. And you can see, right, the pattern begins to emerge, right? Let's write all of the combinations. For if I was to roll a 3 on the first die, so I could roll a 3 and a 1, a 3 and a 2, a 3 and a 3, or I could roll a 3 and a 4. Next thing is all of the combinations that I could have if I rolled the 4 first. So I could roll a 4 and a 1, a 4 and a 2, a 4, excuse me, choking here, a 4 and a 3, and a 4 and a 4. And that is our sample space, otherwise known as a probability model. And it is all of the possible combinations that I could have if I rolled 2 four-sided die. And we'll see that this actually lists our number of possibilities, right? Our sample space. It looks like there are 16 possibilities. I just ran out of words. 16 possibilities there. So let's also write what the probability is that the sum of the numbers is 5. And remember, if I define A as the sum is 5, then if we were to look at the probability of A occurring, right, that's going to be, we're going to have some successes. In other words, is our number of successes. How many combinations add to 5 over our, our total possibilities, okay? So in this case, which ones are successes? Another way to say that is, which ones add to 5? Which ones of these combinations are going to add to 5? And it looks like I'll have 1 here, right? And I'll look through the 2s, and it looks like I have 1 possibility here. Look through our next row, and it looks like I have 1 here. And then looking through the next row, I have 1 here. So that means that there are 4 successes. There are 4 different ways that I could get a sum of 5 if I'm rolling 2 4-sided dice. So that would mean that there are 4 successes, and my total possibilities, there are 16 different ways that I could roll, 16 different outcomes if I'm rolling a 2-sided die. My bad. That's a coin. A 4-sided die. So I'm going to simplify that, right? That's 1/4. Let's write it as a decimal. So the probability is 0.25. Not too shabby. All right. So in your homework assignment, you are going to have a problem where you have to write out the sample space or a probability model. The one in your homework is for rock, paper, scissors. I think an interesting thing to think about. And you can start to think of some probabilities with your rock, paper, scissors. Is there a better one to choose? I wonder. All right. Moving right along. You won't have one exactly like this in your homework, but you have one from the previous assignment. Thought I would do another example. This one's got a little twist to it, so I thought it was worth doing. It's worth it for you to see it. Well, so in government data, a household consists of all occupants of a dwelling unit. We're going to choose an American household at random and count the number of people it contains. Here is the assignment of probabilities for the outcome. So the way we read this is, right, there is a 0.25 chance or probability that there is 1 person in a household, right? 0.32 is the probability of there being 2 people in the household. So we don't know 3 or 4. We'll figure that out. In fact, the first thing that we're being asked is what probability should replace those question marks in the table. It says that the probability of finding 3 people in a household is the same as the probability of finding 4 people, right? So essentially, these two are the same. So once I find what's missing here, I could divide it by 2, right? And then I would be able to find each of these missing probabilities. All right, well, remember, these probabilities have got to add up to 1, right? So what can I do in order to find that? I will take the complement. So 1 minus all the other stuff, right? If we add these all up, right, it's going to tell us, how much more we need to get to 1. And that amount, how much more, is essentially, not essentially, it is exactly the answer. All right. So let's go ahead and add these up. 0.25 plus 0.32 plus 0.07 plus 0.03 plus 0.01 gets us 2. This is now 1 minus 0.68, which is 0.32. Okay, all right. So then that means that the question mark, right, has got to be 0.16. Right, because we had to divide that by 2. If they're the same, then they're both going to be 0.16, right? And there we have that. Let's also look at the probability that a chosen household contains more than 1 person. So what does that mean? That means that it could be 2 or 3 or 4 or 5 or 6 or 7 plus, right? So I'm going to write that down. It's the same thing. So this could be, that's the probability of 2 plus the probability of 3, plus the probability that there are 4, plus the probability there are 5, plus the probability there are 6, plus the probability that there are 7 plus members in the household. And you could add all of these up, right? Use your addition rule to find it, or we could maybe use the complement rule, right? Isn't it the same thing as 1 minus the probability of 1? We could also use the complement rule. These are all the same. I would like to do that because it is less work, right? And I have a tendency to try to do less work, not because I'm lazy, but because I'm efficient. Maybe I am a little lazy. I'm not lazy, actually. What it is I want to get this stuff done faster so that I can do the stuff I really love. Okay. I mean, I do like this. I'm passionate about math, but I would rather be snowboarding. So, you know, if you're more efficient, then you have more time to do stuff you really want to do. All right. Let's do another one. This one is like the one that I've given you guys on or that we've given you guys on the assignment for today. So if you choose a young adult age 25 to 29, that's what they're saying a young adult is. At random, the probability is 0.13 that the person chosen did not complete high school. 0.29 that the person has a high school diploma but no further education, and 0.3 that the person has at least a bachelor's degree. What must be the probability that a randomly chosen young adult has some education beyond high school but does not have a bachelor's degree? Why? Well, what in the world? I never read anything about a person having some education beyond high school in the problem, but not a bachelor's degree. Those people are not in the original setup. So I'm thinking maybe the probabilities that they gave us don't add to 1. So let's check that. Let's check that real quick. So let's see. Let's see if there's a missing number. And we'll be able to find it using our complement rule if we need to. What is that sum? Yes, I can do that. It's 60 plus 13 minus 1. Okay. All right. Okay, so I mean, if that was all the probabilities, then that should have added to 1, right? All of the probabilities in our sample space should add to 1. So then what I'm going to say is that I think that in order to find the missing one, we'll have to subtract from 1. So that will be 0.28. And hey, if it's asking why, I mean, when I do this, I'm explaining why. Right? Mathematics is an explanation. Okay. Have I answered the question? Yes. Cool. How about the probability that a young adult completed high school? Okay, so what's the probability that a young adult completed high school? Well, we know that 13% or 0.13 did not complete high school, right? The probability is 0.13. You know, we could add up everything else, right? And subtract from 1, but wouldn't it be the case that if I define Right? Everybody but the people who did not complete high school completed high school, right? So we could take the complement. We would get whatever's left. I mean, you could do it another way. You could also add them up and subtract. You could also add up, right? All of the people. Sorry, I was looking messy. You don't have to do it this way, is what I'm trying to say. You could also add up the probabilities for all the people that did complete high school, right? A little more work, a little easier to use the idea that this is everyone else, right? 1 minus the people that did not complete high school is going to be all the people that did complete high school. So we will calculate this, and there we go. Which rule did I use? I'm going to answer that question. I used complement rule. All right. And last but not least, gosh, I guess it turns out that it's kind of a shorter lesson today. Don't drop everything all the time. Okay, a little bit shorter lesson today. Let's do this next one. What's the probability that a young adult has further education beyond high school? Which probability rule did you use? Okay, has further education beyond high school. Who are these people that have further education? What are the probabilities, I should say? So it's 1-3 that they didn't. So the person has a high school diploma there. This guy graduated from high school. This guy, right? There's a 0.3% chance that they graduated high school and have a bachelor's degree. And then also we figured out that these people, this probability corresponds to people who graduated high school, have not graduated from college, but have done some education beyond that. So what should we do? We should use we're going to use the addition rule, right? So we're going to say that's 0.29 plus, where did I say it was 0.30, right? And then 0.30, 0.28. 0.87. What rule did we use? We used the addition. Alrighty then.